Greetings, Saintsmen. Welcome to lesson 10.2, which is finding angles and arc measures. We're going to start with some definitions here, which is the sum of measures with central angles with no interior points for a circle is the following. All right. We're going to measure for now. We're going to get back to in a little bit later in the chapter. We'll talk briefly about the uh, idea of what a radian is. Okay. Another way for us to measure degrees, and I'll show you guys how you get that. But for now, what we're going to do is we're going to have the center of the circle. That some of the measures is going to be 360 degrees, which I think most of you guys are comfortable with because that's what you've just utilized in your previous math classes and your previous knowledge that you have. So if I'm going to create an angle like this, from the center, this angle right here, that space in between, is what's referred to as, by no surprise, the central angle. And the sum of all those for a circle will be 360 degrees. A diameter, you're going to see, is going to create, is going to go through the center of the circle and cuts the circle in half. And we'll be able to do some arithmetic on how we get the rest of the varying degrees from there. So here we go. Let's go ahead. Get into the circle here. Oops. Yeah, I'm going to turn off the outer shapes for a sec. Right. And I'm going to draw the following. Oops. Get my diameter a little bit cleaner here. This is going to be point T right here. This is Q. This is R. S. U. And V. All right. So what we have here is circle T, where RV is a diameter. And remember what a diameter is. A diameter is a chord through the center. All right. And then we're going to find the measure of angle RTS. Okay. So, how we're going to do that? Well, here's what we're given. We have 8x minus 4 degrees here. We have 13x minus 3 degrees here. And we have 5x plus 5 degrees. For that angle UTV. And then for QTV, I have 20x degrees. All right. So here's the big thing is that all these guys form that semicircle or that half circle. Okay. So if I do that, I've chopped this thing in half. So if the entire thing is 360, half of it would be 180. So the measure of angle RTS, right? This guy, plus the measure of angle STU, plus the measure of angle UTV, all makes that semicircle, which is going to be equal to 180 degrees. All right. So what I want to find is RTS. And what I'm going to have to do is first find what x is. So I'm going to substitute here. So I have 8x minus 4 plus STU is 13x minus 3 plus UTV is 5x plus 5. And that's equal to 180. All right. And then now I need to combine my terms, combine my like terms. So I'm going to underline all my x's. Okay. So 8x, 13x, and 5x is 26x. And then I have my negative 4, my negative 3, and my positive 5, which is negative 7 plus 5 or negative 2. And that's all equal to 180. And add 2 to both sides algebraically. So 26x is equal to 182. And then divide both sides by 26. And I'm going to take the time. Again. Fire up my Texas Instruments calculator. These guys who should probably, oops, oh, didn't look so easy all of a sudden. There we go. And I had 180. Divided by 26. And that was, I'm sorry, 182. Which is 7. Right. So, that's not what it asks us for. It wants the measure of RTS. So we're going to take that 7 and we're going to plug it back in here. Okay? So the measure of angle RTS is equal to 8x minus 4, which is going to be 8, times 7 minus 4, which is 56 minus 4, which means the measure of angle RTS is equal to 52. All right. Let's talk some more vocabulary here. Let's get some auto shapes going here. Okay. Make a big circle. Draw my center. Draw a diameter. So chord through the center. Draw another radius. And I'm just going to also put another point here. So I'm going to have A, B, C, D, and E. D's a little extra. So here's how I name these things. Okay. Circle B. I have 3 types of arcs here. I have what is called a minor arc. A minor arc, by definition, okay, we're going to only use 2 letters, and it is a minor arc, for example, AC. But rather than putting a line segment, I put a little arc over the top of it. That means I'm going to go from here to here. When I have a minor arc, it has to have an angle measure that's less than 180 degrees. So this might remind you guys of our discussion with things like obtuse, acute, etc. Okay. We have what's called a major arc, which is defined. For example, I'm going to take CDA. I'm going to use 3 letters. Now, because I use that, C to D all the way to A, right? It told me that I had to go through D. Rather than before, I just went from A to C. I couldn't just go back C to A. That's going to be a minor arc. So to give it directions, I give it that extra coordinate right? So I need that 3rd point to tell me to go a little bit further, all right? And this is going to be a measurement of greater than 180 degrees. And last but not least, I have what's called the semicircle. So what are my other options? I have less than 180. I have greater than 180. And now I'm going to have equal to 180. So for example, I could have arc CDE or CAE. Okay. And this one is equal to 180. Alrighty. Next. Let's do some problem solving. All right. This is one of those things where you guys are going to stare at this a little bit. And I get a lot of the, Mr. Granos, how do you know? Well, the reason I know is because I didn't just pull out of thin air, and I'm using my reasoning to help me solve these problems, okay? So let's see here. I'm going to go, oops. diameter there. Let's see here. Go here, radius. And here, another one here, another one right here, which I'm going to write a right angle. Okay. And here is what these guys all are. I have J, K, L, M, N, O, and this is going to be circle P. Okay. So in circle P, the measure of angle NPM is equal to 46. Okay. PL, so this bisects angle KPM, and last but not least, OP is perpendicular to KN, which we marked on here, okay? So, here's what we're going to be solving for. 3 things. First one, A, is the measure of OK, arc OK. B, we're going to look for the measure of arc LM. And C, we're going to look for the measure of arc JKO, which we should already know is a major arc, right? JKO, right? It's going to be greater than 180 because we use 3 letters there. It's going to be a quick question I'm going to ask you guys during class. See if you're paying attention, right? To this. How do you know that it's a major arc? And there'll be 5 or 6 guys right off the bat. They're going to shout it out. And those are the guys who I know are doing their work, okay? And are getting prepared adequately. So, okay, how do we figure it out? Well, okay is going to be this right here. Now, KN, as we saw, is a diameter, right? So that's 180. And then if the ON, right, OPN, that is a right angle because OP is perpendicular to KN, then what we got here is another 90-degree angle, right? Because they'd have to be supplementary. And then here we go. How about LM? Here to here. Well, how do we figure out LM? Interesting. All right, well, let's see here. NPM. NPM is 46 degrees. Okay. Now, how much would this be right here? JKP. Well, this one will also be 46. Okay. Which we should know because these arc measures are going to correspond to these central angles. Sorry if I that was something I failed to discuss here. Okay, so these arc measures are going to correspond to these central angles. So LM, how are we going to get this guy? Because this guy's 146. That's 46. Okay. Well, could we figure out what this one is right here? Okay. Or could we figure out this angle right here? Okay. Man, what other strategies do we have here? Oh, well, we have a 90-degree angle here. Okay, so this one's 90. This one has to be 44. How on earth could we get LM? Right? Let's see here. Well, we know this entire thing's got to be 180, right? Because there's... So, the question is, what would this guy be right here? How do we get that? 46, 46. Okay. And LP, I think some of you guys are like, oh, it's vertical. No, no, no. This would OL, you guys are seeing here, and I'm going to exaggerate this one a little bit. It's like that, right? Now PL bisects KPM. Oh, well, we know this. These guys have to be congruent. Excellent. So if we know this entire thing is the semicircle, right? We're going to go 46 plus x, and that's going to be equal to 180, okay? Or 2x is going to be equal to, after you subtract 46 from both sides, is 134, and we got it. X is going to be equal to 67. There it is. I know, that's what I was setting up for the entire time. All right, 6, 7. JKO. So last one here. All right, that's our major arc. So J to K to O. All right. It's the entire circle, but we got to back out that 44 right there. Okay. So we're going to go, it's going to be X plus 44 give us 360. So we back out 44. And that is going to give us 316. All right. I had a good time there. With that 6, 7. Last, I'm going to skip a previous example. Actually, you know what I'm going to do? See if it's, I maintained that example years ago for audio. Nah, I took it out. So let's go ahead and just get one more thing for us to do today. All right. Diameter, ABC, BD is radius. Okay. So we have circle B, and AC is equal to 9. And the measure of angle ABD is 40. And we're going to find the measure of arc AD. I'm sorry, we're just going to find arc AD. Now the measure. The measure would be a corresponding angle. And now we're going to find length. Okay? So, how do we do that? Well, we're going to take the angle measure to the whole circle is going to be our ratio we're going to have here. Okay? So, for AD, right? For ABD, that was 40 to the whole circle, which is 360. Okay. And then here we have arc AD over the whole circle. Now, how would you figure out this whole circle? It says AC, which is a diameter, right? So for that whole circle, the circumference is going to be pi times that diameter, okay? Circumference, again, is equal to pi times the diameter. This is something we talked about just recently with the fire pit problem, right? Diameter is that length across, and what pi is going to be equal to, it's a ratio. It's whatever you do with the length all the way around a circle, okay? It's that measurement around it, kind of like perimeter for a polygon. And then you're going to divide it by the diameter, that length across it, and that ratio is pi. It's a little bit over 3.1-ish, okay? So, let's actually clean this fraction up. We have 40 over 360, which is 1 over 9, and that's equal to AD over 9 pi. And we're going to do a cross product. So I have 9 pi times 9 times arc AD, right? And we divide both sides by 9. So the measure of arc AD, or the length of arc AD, that is pi. All right. Good times. You guys have questions? See me during office hours.